Let's now talk about graphs. Um, for many years, I think SAS had a graphics functionality that was difficult to use. Recently, they've come out with some procedures that I think are absolutely excellent. I love SAS's graphical capabilities now that they have sgplot and sgpanel. Let's go run a frequency distribution of payment type. So this is from that defaulting customer data set that we've been analyzing since 451. And if we want to make a bar chart of this, you use proc sgplot. And so sgplot offers many different individual commands. So maybe if we go back here, how do we get help? We could just Google it, or you can come back here and click on it. And so if you look at the help for this, you get a list of all the things that it'll do. So it does bar charts, it does box plots, it does density plots, and so forth. So let's go see how we make this bar chart. It's very simple. We just say I want a vertical bar chart. So V bar means vertical bar chart, H bar means give me a horizontal bar chart. Then you list the variable and you get the frequency counts. And so that's how we get a bar chart. What about a histogram? Well, it's the same procedure, proc sgplot, but we're going to use the histogram statement along with the variable name to get a histogram. How would we create the log version of this? Well, the first thing I'd have to do is first log the variable. So I'd have to make a new data set. Actually, I overwrote the original data set with this new variable. So this would be the equivalent of transform compute in SPSS. And then make a histogram of log down inside proc sgplot. So that's histograms. What about box plots? Well, again, we're going to use sgplot. We're going to use the vbox command to make a box plot. So let's make a box plot of log down. Now, if you want to break it out by different values, we specify a /category option. So let's break out the down payment amounts by payment type. So that's PMT type. And so you get this, this box plot. Now we could break it out further with a group option. So we could, in essence, we're saying, how does your down payment depend on both the way you pay your bills as well as your gender. And so gender is now encoded with color, red or blue, and we see the payment type on the horizontal axis. So another thing that you may want to do is to create bar charts of how some variable depends on another. So for example, what percentage of people default based on the way they pay their bill? So we make a V-bar of payment type that specify what goes on the horizontal axis. The response variable is going to be what goes on the vertical axis. Without this, remember I did something really similar a minute ago. So here was a V-bar of payment type without any options, and I just got the same as a frequency distribution plotted. However, if you put a response option in here, that means, well, we want to plot something about the default status on the vertical axis. What do we want to plot? Well, I want to plot the means. So remember, the mean of a 0-1 variable is the percentage of ones. So this shows the fraction who defaulted by payment type. Similar graph is one where we would have a line plot. So let's erase the bars but keep the ends. And I'm going to superimpose confidence limits. So this limit stat command, CLM, means confidence limit for the mean. This could have been added to the bar chart as well if we wanted to stick a confidence interval around these. But here you get the exact same data plotted, but without the bars, and the confidence limit superimposed on top of that. Sometimes we may want more than one predictor variable. So we've already seen an example of this group option. So this would create one of these line plots, but now we're going to have colors and the type of line encoding payment type. So here we have the down payment amount. We have the payment type encoded with color and the line type. We could also do this with a bar chart, and you'll see it's basically the same syntax. Specify the response variable, specify the statistic that we want to compute. This is going to specify what to break out the colors by, so payment type. So SAS does multi-panel displays. This is similar to the panel by options in the SPSS interactive graphics module. So the only new part of this is that, actually there's two new parts. One is we're going to be using sgpanel. Everything I've done so far uses sgplot. Here we're going to use sgpanel, and I have to specify a panel by statement. So this specifies which variable to break out in different panels. So that's what panel by does. Then everything else is the same. So if I wanted to break out mean default rate, so here's the mean of default by down payment amount, that's binned, and we want to have a separate panel for each payment type. This is how I create that graph. Here is another version of that graph. However, we're going to add another independent variable, which is how much are you using the club. So notice I've got three variables here. I encode one variable with panels. It's the payment type. Down payment is going to be on the horizontal axis, and then the use variable is going to get broken out by different line types. So that gives you a sense for what you can do with these sgpanel and sgplot commands. There's also an sgscatter command that I think makes very nice scatter plot matrices whenever you're doing a regression. So the basic syntax is we're going to use sgscatter. This is the quality control data set from the chapter 12 case in Siegel. You specify a matrix command and you list all the variables that you want to include in the scatter plot matrix. Another option that I like is this diagonal. So this is going to plot a histogram and a density estimate on the diagonals. So this describes the distribution of each one of these variables in a univariate way. And we get all the pairs of scatter plots. If we want to see how does defect rate depend on temperature, here's the scatter plot. How does density affect defect rate? This would be the one. So this is your defect vertical axis, your rate of production on the horizontal axis, and so forth. And these are very useful regression diagnostics. Sometimes you want to superimpose various things. So let's make a scatter plot now. We'll use proc sgplot. What I'm really doing is I'm going to blow up this particular panel of the scatter plot matrix. So defect rate versus the rate of production. And if I say reg, that's going to give me a scatter plot with a regression line superimposed. So that gives us the line with the points. PB spline gives me a B spline, penalized B spline, which is this curve. And that's a good way to evaluate whether you've got a nonlinear relationship. And this the B spline is telling us that the line may be inadequate for this relationship. We may need something a little bit more curved. Essentially what it's saying is the defect rate is quite low until your rate of production reaches a certain level, and then it increases steadily. If you do proc reg, You'll also get a version of this plot, and this is, I think, an absolutely beautiful plot that illustrates all the key concepts of Chapter 11. The shaded part shows the confidence limits for the mean, so that's confidence limit for the line. Your prediction intervals are indicated by the dashed lines, so 95% of the distribution should be within those dashed lines. So that comes out by default if you use proc2. Another thing that comes out by default in proc2 are a pretty comprehensive battery of diagnostics. So I think this is proc2 does a great job of giving you the plots you need to assess whether the fit is any good. So you get all your residual plots, your normal probability plots, histogram of the residuals, and Cook's distance plots indicating the leverage of individual observations. So it's a very good plot. We can also do multi-panel scatter plots. This is a very famous data set known as Anscombe's data. And what you have are 4 data sets 1 through 4. They all have the same mean of x, mean of y, standard deviation of x, standard deviation of y, same regression lines. But the point of this data set is you need to look at the data because the scatter plots are wildly different. Even though the regression lines and correlations and all that are the same, the data sets tell completely different stories. So the way we do that is with the panel by statement and then the scatter command with sgpanel or sgplot.